Okay, this is the Unit 4 test review for page 1. If you notice at the top, it will tell you exactly how I'm going to grade this test. So level 1 just says check whether each number belongs in each category. It's asking you to categorize things as real or imaginary. Remember, anything that needs the square root of -1 is imaginary. So I look at number 1 and I go, does this need the square root of -1 in there? Yes, it does, therefore it's imaginary. But I look at number 2 and I go, does it need the square root of -1? Is it a negative under the square root? It does not, so it is real. Number 3 says simplify this, saying kind of like combining like terms. I have 3 times I minus 7 times I. 3 minus 7 is -4, so I have -4i. Number 4 says the square root of -64. Well, that's the same thing as the square root of -1 times the square root of 64. Well, the square root of -1 is I, and the square root of 64 is 8, so I times 8 is 8i. Level 2 says simplify each expression. Again, it's just like combining like terms, so we've got 7 plus 3. 7 plus 3 is 10. And we've got positive I plus positive 2i, which is 3i. Number 6, again, we do the real parts. We've got this 6 and this -3. 6 plus -3 is 3. -4 plus -6 is -10, so -10i. What does the symbol I mean in a math expression? Well, we know that I squared has to equal -1. Therefore, I has to equal the square root of -1. So it's a number that when squared equals -1, which doesn't happen in any of the other numbers we have. We use it because we often get negative square roots in a process and end up without them in the end. So it's necessary, or we use them to deal with negative square roots. Okay, level 3, simplify each expression. Now we've got some subtracting and some multiplying going on. So right here, if we, again, just like combining like terms on number 8, we go 4 minus 9. So 4 minus 9 is -5. And then we do -3i, and then this minus sign, and then 2i. So -3 minus 2, if you put that in your calculator without the I, you get -5. So this would be -5i. Number 9 is a multiply problem. Some of you like multiplying with the double distribute, where you multiply this times this, and this times this, and that's totally fine. If that's your cup of tea, go for it. I'm going to do it with the box method because for people who are struggling just a little bit, sometimes it's easier to see what I'm doing there and make sure that I've matched everything up. But if you like the double distribute with the arrows, that's fine. So we write 4 minus 3i and times and 9 plus 2i. And then we multiply each pair. So 9 times 4 is 36. 9 times minus 3 is -27. Keep the I on there, -27i. 2 times 4 is 8, so this would be 8i. 2 times 3 is 6. 2 times -3 is -6. I times I is I squared. So be very careful with that I squared. I squared is equal to -1. We end up with -6 times -1. A negative times a negative is a positive. And then you combine like terms. So we actually have 2 sets of like terms here. We have both of these are real numbers. So we've got 36 plus 6 is 42. And then this one on this direction, 8i minus 27i. So that's minus 19i. So your final answer is 42 minus 19i. And you could also get that if you did the double distribute. Just again, when you get the -6i squared, you have to keep simplifying it because I squared equals -1. Okay, number 10 is again just a subtract problem right here. So we go, oh, look, this one's kind of written weird. It's okay, but it is written weird. They put the imaginary piece first. So here's -i minus 4i. So I've got -i minus 4i. So this is like a -1 minus 4, that's -5i. And then we've got plus 2 minus 4. So we've got 2 minus -4. Subtracting a negative is adding a positive, so 5a plus 6. Or if you want to write it in the traditional complex numbers, we always put our real component first, so 6 minus 5i. But I would give you in either order that answer. Number 11 is a little bit tricky because it is asking you to multiply, but it's got a squared. So it's saying 5 minus 2i squared. And so we've got this problem right here. So we're going to have 5 minus 2i and 5 minus 2i. So 5 times 5 is easy, that's 25. 5 times negative 2 is negative 10, so we've got negative 10i. It's repeated down here since it is squared. We get that same number twice. And 2 times 2 is 4. They're both negative, so the answer is positive. I times I is I squared. But again, I squared is negative 1. 4 times negative 1 is negative 4. So scribble that out, rewrite it as negative 4, and combine like terms. Our real numbers are on this diagonal. 25 minus 4 is 21. And negative 10i minus 10i is negative 20i. Okay, then it says, are there any numbers that are not complex? No, there are not. Because any number that can be written as a plus bi is complex. And any number that we've learned about previously, so like let's say your favorite birthday was the day you turned 7, you're like, that's not complex, there's no I part, but we can also write that as 7 plus 0i. So it's 7 in the real dimension and 0 in that imaginary dimension, making it still available to us in the complex system. I always have someone go, well, what about like the square root of 7 over 19? And you're like, well, yeah, because that's the square root of 7 over 19 plus 0i. You can also write that a complex number that's only imaginary. So if you're like, what about 3i? You're like, yeah, that's just 0 in the real direction and 3 in the imaginary direction. So whether it's completely imaginary, completely real, or an angle of both, you can write it as complex.